So yep, welcome to Algos in 10, Season 9, Episode 3, Among Us. And it's a triple header. So we're basically going to play the game Among Us with algorithms. And also to make sure that things are not very sus, I have Among Us goggles as part of my Zoom, outfit, I guess. And of course, today's episode is sponsored by Fengwa Mooncakes for, Chinese Mid-Autumn Festival. So these are beautiful mooncakes. You got lotus mooncake, you got shuanghuang or double yolk mooncakes, or if you're watching for those triglycerides and diet, you got also some amazing sesame and red bean mooncakes. So yeah, this is an amazing opportunity to just share part of my cultural and mental health background. And of course, you saw right there, I have my boys from 2Hype, formerly Mopi, Cash, Jesser, Jidel, those guys. It's a really great game Among Us. And honestly, it's like an amazing game with like tons of Schadenfreude, tons of just general stuff. So a little word about today's episode. So it's called, of course, the code is sus, which means for the millennial speak, it's called suspect. And today we're going to actually give a moment of silence for the 9/11. All right, fantastic. Now I'm going to actually get rid of this crazy little getup because I don't want to look silly in today's episode. So that's all good. So yeah, there we go. Back to reality check. Back to real life. So here's today's episode. Algos in 10, Season 3, Episode 9. The Imposter is Among Us. So this is a game that has elements of Schadenfreude, accusations of sus, and well, low-key was the only reason why my mental health in the tail end of my Northeastern's master's degree, I could even be able to do any project work with data science while applying for a job. However, also represents a topic which can be tough to discuss with computer scientists and people and STEM in general, imposter syndrome. So yes, I do suffer from imposter syndrome, hence the reason why I'm playing the game Among Us and going through sus times. Sometimes I feel very sus or suspect in my ability to even solve any leak code, get into jobs, or even think my degree or academic achievements worth anything. Also, coming from an Asian American background, it's very hard to talk about mental health with parents and relatives from a Western perspective. This is why the episode today will be truly focusing on mental health and computer science, while playing some Among Us. The episode is brought by the classic 2015 mental health Pixar classic Inside Out. We had disgust, fear, joy, anger, sadness, those type of emotions. So here's part A, which is called Sussing Out the Imposter. It's related to Gale's CTCI chapter 16, problem 19, pond sizes, which is actually a very famous interview question for recursion. There's an imposter, a spaceship with passengers with types doubt, anxiety, depression, worries, and for some reason down bad. The passengers in the spaceship have also not been touching grass or, slang for not going outside for almost a year due to certain pestilence from Earth from a certain origin. The types doubt and anxiety are mental, therefore 0. The types depression and worries are emotional, therefore type 1. Finally, the type down bad, a millennial, Gen Z new type is digital, therefore type 2. And of course, right now my Docker is behaving very sus because I just managed to reinstall this bad boy, but I'll let him do his thing. So after some rancorous debate, surprisingly a rich discussion about pros and cons about witch hunting each other, like pointing fingers, witch hunting each other, who is the imposter, and some infighting over Chinese sus mooncakes, with the following decision to kick out the passenger. We have each inhabitant in the spaceship designed by a grid system and that there are connected accusations between each inhabitant. If there are 0 between inhabitants, that means they do not accuse each other of being the imposter. If there is a 1, that means they do accuse each other of being the imposter. Here's a sample grid system we're working with here. 0, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 0, 1, 0, 1. And no, they're not 6, 5, 13, and 5 in binary. They're just, random grid coordinates. It would not be a bad thing to make this problem more challenging and more sus. So come up with an efficient quadratic time O(n) squared worst case divide and conquer recursive algorithm to determine how many groups of suspect imposters there are. The group with the lowest number gets kicked out of a spaceship and was the imposter. So you can see there's a little flavor of Among Us. And as I mentioned before, this is some nice 2Hype embedded video in this episode, and shout out to 2Hype for cooking, basketball, and NBA 2K stuff. Very, very fun. So I'm gonna stop sharing my screen and then basically present to you the solution for this episode. Oh yes, Docker is still acting very sus, so whatever. I'm gonna just do what I gotta do. So to begin this episode, we first gotta be able to understand what it means by a recursive algorithm in terms of this episode. So we need to understand basically what it means here. So let me just quickly, set up my screen, make sure things are all good and all nice and even before we continue the episode, because I don't want to work with a very suspect or sus screen in general. So for this solution, we obviously got a public class. So we're going to write public class Among Us. And by now you should know Algos intend always to have like a constructor method to make the object. So we're going to have just 3 methods in the constructor: public Among Us, int number of crewmates you have, int number of imposters, obviously, and then finally int array the members of the crew. This is like a really basic constructor, that's all. And then we're just gonna like fill in the getters and setters here. So now get to the real part of the episode, which is the actual algorithm. So for this algorithm, we have a recursive algorithm. So we basically have one algorithm to compute each group size for the Among Us. And the second part of the algorithm, we then got compute the smallest group size to kick out a spaceship. So to continue this, we first got to actually write the function, of course. So it just returned an array list, which is type integer, of course, because we're looking for the number of crewmates and compute group size. And take 2 variables, take int crew here, and you also take in also another int, basically the type, the mental health type they have. So the first part of the function is really simple. 1, 2, 3, 4, if type not equal to 0, or type not equal to 1, or type not equal to 2. So if it's none of the actual types we talked about, the types 1, 2, and 0, 1, 0, 1, 2, return nothing. So return basically null. Otherwise, you do the following. You make an array list. You use a pattern called DFS, which is depth first search. So you do like a visited of a traversal tree. So you do Boolean. Instead of visited, I would use the word investigated, because it is like one of those meetings in Among Us where you investigate who killed who, basically. And you have a new Boolean array that has basically the size of the crew. So crew.length. Is this job using .length, and then crew column.length. Column 0.length. And you basically then traverse the array to check who is sus. I'll give you a hint for those who try and actually count how many times there's been sus in this episode. 1101. This is a special end of the episode award, which I'll tell you later. So you got for int I equals 0, I less than crew dot length I plus plus. So it's a double array, so it's O(n) squared algorithm here. So then you got, for example, for int j equals 0, j less than crew of I dot length. You're basically traversing an entire like I by j grid. So it's not necessarily square. It could be rectangular, it could even be jagged. Just it's a general array size. So we just keep on coding some Java here, and this is where it gets interesting. You call it a recursive helper function. This is a divide and conquer. So you can see this is all the way going back to the first ever episode Algos in 1. It's a complete throwback, which is fitting for my move out season for going to Florida. So it's going all the way back to the beginnings of this entire channel, basically. So we have int, and we're not going to use those size here. We're going to use actually int crew size instead. And we're going to use the helper function called compute min group size. And that only takes in 4 variables. So you take in the crew, you take in investigated, which is like whether you have been, checking if this guy's sus or not. And then you have I and j. Of course, this is very important. Each time you have a sus crewmate in Among Us, you add in another person that you kick out. You don't want to have like nobody in the spaceship. Otherwise, the game is already over. And you don't play Among Us. You basically play, Uno in reverse. So yeah, crew size dot add. Make sure you do it correctly here. Oh yes, crew size is dot add crew size. So I did forget one little thing. I forgot one little thing, and this happens in interviews sometimes. You forget little things. So you have another array list of integer type crew sizes, and it basically tells you how big the sizes are. So you basically first make it an entirely empty integer array. And there you have it. So that works well. I'm going to just import Java util to make sure I can actually use arrays here. Dot star, and that should be good. So now we got the helper function to compute the smallest group size to kick out of a spaceship. So that's another public function here, public. And this returns an int. So it returns the minimum number of the size array for like the crew size members. So public int compute min group size. I'm taking 4 variables for this method. First variable, of course, is once again the same as the other ones. You reduce, reuse, recycle, reuse the int double array crew. Next, you of course reuse the Boolean investigated. So this is what I love about this function, is that like you can reuse everything and not have to rewrite code. No wonder Gil loves this problem. I would too. I would love it as well. You don't have to rewrite code. Less errors, more offers. Very good. And then you also got int row, int call. So this is getting interesting because you don't really have boundaries in space like in an actual array. So for sake of pedanticness, I'm actually going to do the following instead. If out of bounds, game over. So basically, if of course, row is less than 0, or column less than 0, or the row is greater than basically the crew size dot length, or a column, is greater than the crew of the let me think. Oh yes, the crew of the row dot length. Or if it's already been investigated, like the person already been checking whether you actually have like person sus or not, row call, or the crew of row call is not equal to 0, which you already investigated it. You do something very simple. You don't return 0. You actually do the following. You first sys.print game over, basically. So the game is over for Among Us because nobody else is back. Nobody else is in the system. and then you return, of course, 0. Otherwise, you reverse some recursion here. So this is where recursion kicks in here. You recurse on each of the remaining. So you can see Among Us is quite recursive, right? You accuse one person being sus, then the next person being sus, then the next person being sus. And look at that. Another hint for how many times I've calculated said the word sus in Chinese, 二十一. So yes, recurse each of the remaining suspect crewmates in Among Us. So you do recursion algorithm here, and then you basically have, whoops, my bad. That was not supposed to happen, my bad. All right, yes, I gotta be careful with that. So sometimes, the computer can be a little bit sus, and it does happen, like it's hard to control what you have on your Mac. So that's why I recommend Dropbox, by the way, to like keep track of things inside your PC. So anyways, I recurse here, int crew size equal 1. Then I basically have another array to check how many times I investigated it. So the investigated row, column, equals true. So like, eventually you have to say everybody was originally suspect or sus. But you should also make sure you don't double count sus people. Otherwise, you have double the accusation, which is not good for Among Us. You have people accusing of cheating, and then the crewmates get all sorts of messed up. This is a very, very sociopathic game. Sometimes I have to say. So this dr value, actually, I'm gonna change it up a little bit. This rr variable is sort of like counting backwards from like one group size of the Among Us crew into like the entire spaceship. So let's say, for example, Cash be like, rewiring the router, and of course, Jaida be shooting up, little asteroid ships or whatever, those Among Us mini tasks. This is like how you basically recursively calculate how many times you've done the mini task. So that's another for loop O(n) squared algorithm. So you can see this algorithm is quite nice to write. It's not hard to understand unless like you don't know recursion. Like by far, this is the easiest algorithm to understand in Algos in 10, like in terms of Gale questions. It's not as bad as even like the questions in episode 1 back in Mother's Day. Those are actually hard to understand because you have to understand, bit manipulations. Anyway, I keep on yapping about algorithms. I do crew size plus equal, and here you go. There's why I use the recursive function compute. So compute min group size, crew, crew, investigated. And now you have to be careful because you're looking for each piece of like the spaceship. You want to have then row plus RR and then call plus CC. And there you go. There's your algorithm for Among Us. So now I'm going to actually, share the sound to show how does, our amazing guys into hype play. So I'm going to share the video again for 2 hype. So you can see they played the game Among Us with various games, and that's pretty cool. So now we get to part B, services and networking Among Us. This is a power transmission. We've actually also lost power in the spaceship, so nobody can use any service and networking to accuse each other of being suspect in the spaceship. For the unusual case and a bit special experiment, since the solution comes only when all the pieces are working, unlike a real download file or chords, or blast asteroids from Among Us mini task, the remaining inhabitants have to work together to fix the issue. This is a task that everybody has to complete as well, as opposed to the individual. And this is my own problem for the creation, not a CKD official examination question, and it'll be the last Kubernetes related portion for Algos Intense Season 3. So yep, big sad, no more Kubernetes after this episode. So you have the following Kubernetes coding to get started with how to fix the power outage in the spaceship. If they fail, the episode ends and it's game over. So you have service among us.yaml, you have MySQL among us.deployment.yaml, you have PowerSwitch.yaml, you have among us deny suspect.yaml, you got policy WordPress among us.yaml. So your job is simple. Come up with a complete Kubernetes solution that solves the missing parts from the deployment. It connects both the service and network policies to reveal the encrypted password and save the game. And now to end the episode, how many times was the word sus used in this episode? I'll give you another hint in Spanish. 30 y 3. Special subscription to a person with the closest answer. Like and subscribe and don't be suspect. So the reason why I'm not going to show you any Kubernetes code for this is because, Docker is being very sus. I just said it again. So yeah, I will show you guys in my GitHub coding solution how this Kubernetes service will work. So yeah, enjoy September and like and subscribe. See you guys later and don't be sus.